Hello, everyone. My name is Ricardo. I'm from Group Free. All good things are free. So today we are here to explain you how to determine the value of a specific case study. And therefore, I'm here with my colleagues, Sahin, Nora, Claire, Konstantinos, Rita, and Pramanir, which will then show you the following slides. So the next presenter will be Sahin.
Yep. Okay, so to determine the value in use, in this case, we are going to use the relief from royalty method. So this is based on the fictional idea that the company doesn't actually have the technology yet, and it's going to have to in-license the technology from someone else. And in doing that, in return, it has to pay some royalties. So for the sake of valuation, we use the royalties as the incoming cash flow. So this method is sort of a mixture of both the market approach and the income approach, because you use comparable royalty rates, and for the income approach you use the discount factor to calculate the net present value. So actually the formula calculates the value over a period of time starting from T0, which will be the time at which, say, the company wishes to acquire the asset, until the useful time for that asset. The turnover will be the income that the company earns by using that IP, and you multiply that with the royalty rate, and also factors such the reference parameters, which will include like legal criteria like the enforceability of the patent or the validity, the geographical coverage, etc. And also competition related criteria like whether there are any substitute products around. So you factor all of those into the income, and you multiply that by you subtract the cost from that. So the cost will be the cost you incurred in sort of creating the IP, and you divide it by 1 plus WACC, and WACC is the weighted average cost of capital. In this case, it's the discount factor, and you compute that over a period of time T. Yeah.
Thank you, Sachin. I will going on with assessment of useful life. There are different factors we have to consider, and there's on the one hand the maintenance, the duration of usage, and also the product life cycle and the technology life cycle, which are different points that deal with the patent and the product and have to be considered further. We see that Schneider has 6 patents at the moment. There is a maximum maintenance period between 11 years for the patent 1 and 16 years for the patent 6, the youngest one. Further, there's a hint that the product life cycle is at the beginning, and there's no action of competitors that is assumed that the development substitute will take 6 years or longer. So the time the competitors need to develop around is the time we thought that it's good for our patent portfolio's useful life. So this should be also 6 years. That this is a time where we can block the competitors so they can't just copy our ideas. And now Claire will going on.
Thank you.
So now we need to detect the share of the patent in the value of the relevant sales. So the product is a highly technical product. and there is no substitute for it because it's completely new. The value of it is really related to the technology which is in it. It's a machine, and you cannot do without the machine. So for the whole machine, the technical part in the product is very high. It's estimated to be 75% because it's highly innovative with nothing special on the similar on the market, and the share in the product of the brand and so on is not so high. The real differentiator is the technology here. And it's even more for the spare parts because most of the patents are not dealing with the whole machine, but on specific parts of the machine. So for the parts, the real value of the part is linked to the patent.
So the next step in the process is to try to calculate the royalty rate, which is needed for the final calculation. And to do that, we are going to compare with license rates that have been given to comparable products in the past. However, because we cannot make a one-to-one correlation between these older licensing rates and where we are today, we have to interpret these license rates and the transactions that took place and model them somehow in order to have a more accurate correlation with our own patent portfolio. To do that, we are going to use a linear model that you see on the screen, and essentially correlates the royalty rates with a parameter that is called score, and represent essentially the quality or the strength of our patent portfolio in terms of quality and technology. The royalty rates that you can see are retrieved from commercially known royalty rates that happened in the past for comparable products, let's say, and they span from 2% to 6%, while an average patent portfolio in terms of quality and technology should score about 4%. The score of our patent portfolio, the score is actually the score of our patent portfolio, and needs to be calculated. And in order to try to make a calculation, we're going to model it as a sum of 6 individual scores, each of them corresponding to one criterion. So these 6 criteria, you can see it are in these 6 tables, are scalability, technological coherence, technology lifecycle, unique selling proposition, substitutes, and competition. And for each of these parameters, there is a score attributed, which goes from can range from 0.8 to 1.2. So an average score is 1, the maximum is 1.2, and the minimum is 0.8 for each of these parameters. And the final score is simply the sum of all these scores. So, for example, by taking into account the information that we received based on the level of the development level of the product and the associated process in correspondence with the available patents in the portfolio, we can say that the product and the process claims are fully implemented in serial production. Therefore, we attribute the maximum score for scalability 1.2. There is a high level of there's a high level of technological coherence, although it's mostly functional units that are protected. So we attribute a score of 1.1. We are, as my colleagues previously mentioned, we are relatively at the beginning of the technology life cycle. So we attribute a high score of 1.1. There is certainly a unique selling proposition because right now there are no comparable products in the market. So we attribute the highest score 1.2. For the same reason, we attribute the highest score for substitutes because there are no substitutes. At least we cannot see them in midterm. And there is certainly competition in the market, but no one who can have something relevant as we do. So very few competitors actually have something comparable. So we attribute a high score of 1.1. And that brings us to a total score of, if we add all these numbers, we end up to a total score of 6.9, which corresponds to a rounded royalty rate of 5.5%.
So when we are going through a valuation of a patent portfolio, also other influencing factors must be assessed, like legal risk factors. And what we do here is basically we are calculating the legal risks and discount them from the values. And what we see here is we have a default discount rate, which is basically as if we didn't know anything about the current situation and the context of the patent portfolio. And we have an applied discount calculated, which is based on the background knowledge, on the context knowledge, what we see from the case study paper. So we can distinguish between the overall legal risks, such as geographic scope, status, like is it patented already or is it an application yet, patentability, whether we are able to register a patent for the solution, for the product. And there are the particular legal risks, such as the breadth, like the scope of the patent, like the detectability of the infringement. So how fast we can see that there is an infringement to our patent. And compared to the default calculations, we reduced basically in almost all the cases the applied discount, coming from the fact that we know that Schneider has a very unique, very novel technology, which is relatively well patented and is in line with the geographic expansion scope of Bauma AG, who wants to actually put these products on the market. So how we see it, like countries and status of the patent, we are staying relatively well here, because this is like the first plan is to expand in Germany using the already existing distribution networks of Bauma, and then to extend to France and the UK. So when we look at the given information, the patent statuses are relatively in line with these business strategy. With regards to ownership, we have no specific problems, because this is a startup, Schneider is a startup, so there is no ownership related issues at the moment. Actually, the venture capitalist wants to exit from the situation, so we have no threat from this, so we could reduce it in a very, very large percent. With regards to patentability, we have here some sort of risks, and we have to actually align with the patent department of Schneider. And with regards to the freedom to operate, we could reduce it again, because the uniqueness and the novelty of the technology, and actually that they say that they have, or it's visible from the case study, that they have no real competitors. The scope is aligned, so here we have the same applied discounts, what is basically without with the default discount. And the breadth is basically here we analyze the situation from the specific products, and it seems that it's not necessary to apply this 50% of discount because of the technological novelty again. And the enforceability is again quite easy in a way that relatively low risk, taking into account that the technology is Schneider's at the moment. So when we add these discount rates and multiply them, then we end up in a total risk value of 43%. And with regards to the total calculation of the patent portfolio value, I will give over the baton to my colleagues to give a complete overview on the patent portfolio valuation.
Thank you very much, Rita. So now we come to the part where it says, okay, now it's all about the numbers and the actual value of these things. So we we collected now all the pieces that we need to get to complete our view on the value. And I will now present first an overview of this table in the first half, and then my colleague Branimir will take over. So what you can see on the table is that on the right-hand side, you see the numbers 9, 10 to 14, which is the years of the assumed useful patent life. And then in the first column from the top to the bottom, you have the categories, and that's actually the way how the formula that which was presented as in the very first slides was shown to you how this works. So in the beginning, we have our revenues, which is data which we got provided, and we can read, okay, we have a total revenue of 26 million, or expected revenue of 26 million and 100,000. All the values in the table are times 1,000 euros. Then we split our sales and says, okay, we have sales for the machine itself, and the respective patent factor for the sales, the percentage of it is 75%, which is the weight of the patent for the machine itself, and for the spare parts it was 85. And you can see now it's reducing. In the first years, there's no revenue for spare parts. That's the reason why it's here is empty, and then it starts to accumulate. And with that, we have the total relevant sales that we can use then to, as it was previously, thank you, explained, that we have the legal risk, the asset, so-called asset-specific risk with a certain rate. And from that, we can again reduce the amount and come to 8,417. 8,417,000. And I would like to overhand to my colleague, which is much more better in command in English than myself, Branimir.
Thank you. Perhaps better in English, but less so in mathematics, but I'll still do my best. So we continue from there. It's quite interesting that you see that there we need to, after we we get this number of 8,400,000, we need to apply what's the actual license rate or actual the royalty rates, which are divided for both for the product itself and the spare parts. And basically, this is the factoring in of the percentage. So it's a 5.5 royalty rate, and then you receive the number. So 5.5 royalty rate of the percentage for all the years, for each of the years over there. And there you can see the end number. The total actual license fee would be ranging from 463 to for the 9th, and 700 or actually 700,046 for the final 14th. Afterwards, we need to subtract which were the actual costs which were incurred within the development of those IP rights which were protected. Those would be, I don't know, maintenance. So those would be the development of those rights, and actual those costs which would be around those let's say marks. And we just would subtract these numbers, and then this would be let's say the license fee after costs, which would be reduced somewhat. And after that number, you would need to detract the taxes for which the company would be paying on those numbers. And that's actually we went with the assumed number of the 28.10%. So the numbers which would be receiving there would be even further cleared from that part. So it would range from 324,000 until in the first observed value, and in the last 500,027. Afterwards, further discounting would be taken into account and would take place with the present value factor of the weighted average capital costs of 12%, which was also given. And after applying this, so basically this is something which reflects the fact that the cash which arrives later is less valuable than cash which arrives at an earlier point of time. So then you receive, then as you can see, this factor is also decreasing over time, and therefore the present value of those license fees would be further corrected with the final amount of 289,000 for the first, and the final 267,000. And finally, this would be the end result of the sum of values would be 2 million or 2 billion, actually 205. And then a further adjustment could be made on this number based if we would factor in the actual taxation amount, or actually this would be the benefit within that transaction, which the owner would have for having those amounts which would be considered beneficial from a taxation point of view, because it would reduce the number, the base number or base amount on which the taxes would be due. Therefore, we would apply this factoring, this correcting factor of 1.25. So this would increase actually the value and to 2.757. And by this, we would have the final valuation number. And I would thank you for the attention, and thank you for my part. And then just bring the microphone back to Ricardo and also to our team members. Thank you.
Thank you. You already said everything. So thank you for listening. As you saw, that's the way to provide actually a number behind the patent portfolio. And also the preceding groups, they make very good work to give us all this, and we hand back to our professor. Thank you.